proceed safely outside. Please note floor marshals will guide individuals along the designated evacuation routes and ensure that everyone gathers in the identified evacuation areas. SEARCA Residence Hotel Evacuation Area includes. During the earthquake, security will activate the alarm. Drop, dump, cover, and hold. After the earthquake, walk calmly to the designated evacuation area, the side open parking area. Follow the evacuation routes from your location and proceed safely outside. Head count, search, and rescue. The head marshal will facilitate the head count at the evacuation area. Floor marshals will report per floor. If someone is unaccounted for, the safety committee will begin search and rescue. Minor injuries will be taken to UPLB health service or nearby hospitals using SEARCA vehicles. Facility assessment and return. The safety committee will inspect the building for damage. If no issues are found, the head marshal will declare it safe for re-entry. If structural problems are detected, the crisis management team will designate an alternate facility for business continuity. Emergency response in case of fire. In case of fire, the security team or safety committee will activate the alarm. An announcement will be made through the PABX system to guide evacuation. The head marshal will notify the university police force and local fire stations. Small fire extinguishing. Fire extinguishers are located inside the building. If the fire is beyond control, do not attempt to extinguish, evacuate immediately. To use a fire extinguisher, remember PACS. Pull the pin, aim at the base of the fire, squeeze the handle, and sweep side to side. Please note, fire extinguishers are located inside the building and are maintained by the safety committee.
Dapat yung mga matanda.
Emergency response in the event of earthquake. Drop, cover, and hold procedures. SEARCA HQ evacuation area. During the earthquake, security will activate the alarm. Remember, drop, dump, cover, and hold. After the earthquake, walk calmly to the evacuation area. Follow the evacuation route to the location and stay safely outside. Please don't floor marshal. Guide individuals along the designated evacuation to ensure that they gather in identified evacuation areas. SEARCA Residence Hotel Evacuation Area and routes. During the earthquake, security will activate the alarm. Drop, dump, cover, and hold. After the earthquake, walk calmly to the designated evacuation area, the side open parking area. Follow the evacuation route from your location and proceed safely outside. Head count, search, and rescue. The head marshal will facilitate the head count of the evacuation area. Floor marshals will report per floor. If someone is unaccounted for, the safety committee will begin search and rescue. Minor injuries will be taken to UPL Health Service or nearby hospitals using SEARCA vehicles. Facility assessment and return. The safety committee will inspect the building for damage. If no issues are found, the head marshal will declare it safe for re-entry. If structural problems are detected, the crisis management team will designate an alternate facility for midwife continuity. Emergency response in case of fire. In case of fire, the security team or safety committee will activate the alarm. An announcement will be made through the PABX system to guide evacuation. The head marshal will notify the university police force and local fire stations. Small fire extinguishing. Fire extinguishers are located inside the building. If the fire is beyond control, do not attempt to extinguish and evacuate
All right, hello everybody. Good afternoon. Good afternoon. Thank you so much for patiently waiting. So magandang hapon po sa ating lahat. Welcome to today's session of the Agriculture and Development Seminar Series, or the ADSS. So thank you so much for joining us this afternoon. Whether you are joining on-site or online, we are also being streamed via SEARCA's Facebook page. This special ADSS, we will feature experts on transdisciplinary research in Asia, and in a short while, we will hear from our resource speakers about global to local case studies of transdisciplinarity in action. This seminar is part of the SEARCA-hosted Co-Designing Trainers Training on Transdisciplinarity Approaches workshop, or for the Gearing Up and Applying Inter- and Transdisciplinary Skills in Asia, or the GAIA initiative, funded by the Asia-Pacific Network for Global Change Research. And now, to formally welcome us all to this learning event, let's call on SEARCA Center Director, Dr. Mercedita Sombilia.
Thank you, Sani. Good afternoon, everyone, and welcome to today's SEARCA ADSS. It is inspiring to see partners, institutions, and colleagues from across Asia gathered here to advance our shared commitment through an urgent and timely discussion on transdisciplinary research in action across Asia. The challenges we face today, climate change, food security, rapid technological shifts, and you can name others, require multidisciplinary actions because their impact are interconnected, complex, and urgent. We can no longer work in silos. We have to break boundaries and practice close collaboration across disciplines to connect science, policy, economics, and community practice. That is why today's session matters. It reflects SEARCA's practice to achieve its long-standing commitment to sustainable agriculture and rural development in Southeast Asia. For nearly 6 decades, SEARCA has worked with partners to strengthen institutions, empower people, and build resilience. This session underscores SEARCA's role as a regional convener and international thought leader, advancing solutions that are regional in scope, yet globally relevant. As is stipulated in our 12th five-year development plan with the theme, Sustainable Transformation of Agricultural Systems through Innovation in Southeast Asia, or Sustain Southeast Asia, our strategies are aimed to achieve 4 Ps: improving farmer incomes, or pocket, strengthening food security, or plate, building climate resilience, or place, and empowering people, especially the next generations, or people. These priorities define and guide the work that we do, emphasizing innovation, inclusivity, and sustainability. These outcomes are the urgent needs of the region, and the small steps we do to respond to them would also contribute to the same globally. This SEARCA-hosted event under the Gearing Up and Applying Inter- and Transdisciplinary Skills in Asia, or GAIA, initiative funded by the Asia-Pacific Network for Global Change Research, APN, brings together diverse perspectives from across Asia. This afternoon, we will hear from experts and practitioners, as Sonny has already mentioned, across the region, who are applying transdisciplinary research in real context from Japan, India, Thailand, Mongolia, and the Philippines. Their insights will help us understand not only what transdisciplinarity means, but how it can deliver solutions that are practical, scalable, and impactful. Before we begin, let me highlight 3 reasons why today's session is vital. First, this is about moving from knowledge transformation to systemic change. The challenges we face are not abstract. They are felt daily in farms, households, and communities. What we discuss here must translate into systemic change that solve problems and create opportunities. Second, this is about building bridges. Transdisciplinary approaches allow us to connect disciplines, institutions, and cultures. By drawing on diverse expertise and perspectives, we can create solutions that are innovative, inclusive, and grounded in reality. The third, this is about collective resilience. By bridging together diverse voices from across Asia, we're not only sharing experiences, we're building trust, solidarity, and shared capacity. Collaboration is our greatest strength, and it is what will drive transformation across the region. Let us use this session to spark collaborations that endure beyond today, transforming dialogues into partnerships and partnerships into lasting change. Thank you again for joining us. Welcome to SEARCA, and may today's session inspire us to move from dialogue to action and from collaboration to transformation. Magandang hapon po sa ating lahat.
Maraming salamat po, Ma'am Mercy. And now to set the stage for this seminar, let us proceed to our keynote framing talk. Our keynote speaker is the director of the Future Earth Center at the Research Institute for Humanity and Nature and deputy director of Future Earth Global Hub, Japan. Her experience spans over 20 years as a practitioner and researcher, focusing on environmental conservation and sustainability in Asia. She works as a boundary spanner in the in-between spaces of science and policy, research and practice, and transdisciplinarity. Here to give us the transdisciplinarity overview and relevance, let's welcome Dr. Ria Lambino.
Thank you very much for that introduction, and thank you to Dr. Sumbilya for welcoming us to and hosting us for this particular session and for the workshop. And also want to acknowledge Dr. Angkog for hosting us again. Magandang hapon po sa inyong lahat. Parang tulog pa. My name is Ria Lambino, and I'm here today to give you kind of an overview for this particular session. I'm calling the topic of our seminar for this afternoon is transdisciplinarity, but I'm framing it as, I'm giving the title Unboarded Knowledge and framing it within the context of Asia, especially that our team, we have brought together a small group from the region, and later on you'll be hearing a bit about some of the work that they've done. So allow me to start a little with a self-introduction, if you will allow me, please. And like many of us, I was trained in a specific discipline. I took applied physics, BS Applied Physics in UP Diliman. But I have since crossed boundaries, moving to environmental conservation when I work with WWF Philippines. There at WWF, I work primarily on conservation issues, marine protected areas, and specifically with sea turtles in Tawi-Tawi. For many years, far away down south, in southern part of the Philippines. And for my PhD, I studied environmental policy and governance at Kyoto University, after which I taught at UP in the National College of Public Administration and Government, NCPAG, and Ateneo briefly on environmental policy, environmental science, before moving back to WWF again. This time, I took on a role of Vice President for Sustainable Production, and in this capacity, I worked on different fields on sustainable food and agriculture, water, and energy initiatives, so more of a practitioner on the ground. After that, I went back to Japan in Kyoto at the Research Institute for Humanity and Nature, which hosts the Future Earth Global Hub. in Japan and the Asian region. So Future Earth is a global network of sustainability researchers, anyone working on various sustainability issues. We are a member of our network. It's a global network, whether it's carbon, water, risk, biodiversity, health. We have a Future Earth Philippines program, and some of our colleagues are here. Dr. Angkog is a member of it. And in all of these things, later I'm going to be sharing a little bit about Asia Science Mission. In all of these things, it's essentially different disciplines mixed together. So as mentioned in the introduction, I consider myself a border crosser in a way, and very much kind of a transdisciplinary person. And enough about me. Let's dive into the talk, and maybe let me start by showing you these images, which I don't need to explain very well. You're very familiar with this. We are in a state of crisis. Dr. Zambilla also mentioned this earlier in her welcoming speech. Our forests are burning, we have droughts, and of course super typhoons, and have not yet included the wars that is ongoing in the world right now, which is a very distressing situation. And these are familiar headlines to all of us. We're talking about sea level rise, flooding. Here, especially in the Philippines, we are not just observing climate change anymore, right? We are at the front lines, we are living it already. And so, for example, the Philippines, again, and many parts of Asia, we are defined by resilience, they say. But resilience is being tested by different types of challenges, which are essentially what I would describe as wicked. Okay, not the musical, but essentially wicked problems. We are all experiencing wicked problems. These problems are wicked because they're very difficult to solve. One solution leads to another problem. And as mentioned earlier by Dr. Zambilla, we require a systemic approach. So it needs to be looked at as a whole. It cannot be done in silos. It cannot be done in fragments. And so many of these wicked problems arise sometimes not because the systems are broken. Sometimes systems are perfectly working. Our global economic system, to a certain extent, has been working. That is why we are able to live out the way we live right now. But many of these well-working, quote-unquote, systems create some kind of problematic outcomes, right? Or unintended consequences. So pollution, some of the climate change are caused by some of these interconnected issues, and some of them are unintended consequences. And in order to solve these problems, we need to take a whole of systems approach. And we need systems to be redesigned and to be reimagined. And for this to happen, it is imperative that us in the academic community, the scientific network, that scientific knowledge needs to be harnessed. But again, one single discipline or even two is not enough, okay? Because let's face it, science has boundaries. The way that we are currently oriented at the moment, there are boundaries between science and the non-scientific community. We talk a different language, sometimes very technical, and normal people cannot understand what we're talking about. We're talking about modeling or whatever high-tech issues that we have. There's boundaries between science and policy and science and action. And it's true, these disciplinary walls actually exist. For example, our engineers were working on maybe a very controversial issue, flood control, for example. Are they talking to our sociologists? Are they talking to the people who are affected by it most? Many of our plans, do our economic planners, do they talk to the environmental group? Do they talk to local people who are being affected by the policies that they are implementing? And sometimes when we apply a single lens solution to a wicked problem, we don't really solve it, we just move the problem, the pain, and the issues that they cause somewhere else. And because of this, transdisciplinarity has been identified as one way. It's not the only way, but it's one way that is crossing boundaries to be able to tackle these wicked problems. And in fact, transdisciplinarity has become increasingly popular. There has been a new transdisciplinary buzz. I don't know if you've been hearing it, but everywhere I go now, people talk about, oh, transdisciplinarity. And it's seeing a massive institutional, surge. Just looking at academic publications alone, over the past 25 years from initially, if you search transdiscipline word in the Web of Science or whatever, from 200 articles to thousands of articles at the moment. In the past 25 years, there's been a big search on transdisciplinarity as an approach, as part of the discussions in academic journal articles. And also, I did a recent Google search using the word transdisciplinary center, and I was actually very surprised to see that there are a number of transdisciplinary centers being set up all over the world. There are new centers in France, in Switzerland, in Japan. There are many, not just one. In Singapore, Hong Kong, just the past few years. And so networks and practices and communities of practices such as Future Earth and the Global Transdisciplinary Science are formed around these approaches. There are also conferences such as the Sustainability Research and Innovation, Pacific Asia Summit on Transdisciplinary Education happening in Hong Kong, are being organized to talk about transdisciplinarity. Even scientific funders are increasingly making a requirement that consortia who will apply for their funding needs to be transdisciplinary in nature. So they're no longer just saying, okay, we want the agricultural sector only, or only biology or physics or whatever. So they're really asking for a transdisciplinary consortia. But what is it really? What's all the fuss? Okay, so moving past the buzzwords, allow me to use this kind of Asian culinary lens to kind of distinguish the different types. So we talk about a bento box type. We have this multidisciplinary here. When you can see that the rice is there. There's fish. There's they're all separated in their little boxes, but they never touch. Okay, so that's kind of a multidisciplinary approach. Interdisciplinarity maybe can be likened as a metaphor to a fusion dish, where we mix a few ingredients together. We have biology and chemistry, then you have biochemistry. And then you do agriculture and economics, then you have agriculture economics. Transdisciplinary could really be envisioned as kind of a hot pot. In the hot pot, the disciplines, they simmer in the same broth. In this particular case, if we're talking specifically for transdisciplinary in the sustainability aspect, we're looking at TD, or transdisciplinary, or TD, I call it for a shortcut. The broth is kind of the societal challenge, and they're all together in that one pot. And here you see that TD, they exchange the flavors for the different disciplines, but there's also an ultimate border that they cross. Here, it is not just experts talking to experts, so not just the natural science, social science, even the humanities talking, but here it's also societal. Non-academic actors are part of the process and are being engaged. So it is the co-production of knowledge in this hot pot where you can see that the farmers, their traditional ancient wisdom, is given the same seat at the table as one who has been trained as an agriculturalist, for example, or an economist, together even with a satellite data set, so they're all kind of equal. And if you think about transdisciplinarity, the approach itself probably is not new. This type of engagement we actually see very much at work in Asia region, here in the Philippines, for example. And later on, I believe Dr. Percy will talk a bit more about it today, which I'm very excited to hear about. But there's a whole family of approaches surrounding this. We're talking about participatory action research in different fields. We have citizen science. And, these different family of approaches can be under this banner of transdisciplinarity. Basically, we're talking about science that is engaged. But more and more recently, there seems to be a convergence in terms of the term. So many people are starting to really call it and put it under the banner of transdisciplinarity. So for today's talk, allow me to use the word TD or transdisciplinary, but actually it could encompass some of these other approaches, such as participatory action research, collaborative research, citizen science, and all that. Another way by which we can ask, define TD is also to actually ask, what is it for? What is the purpose, and why do we want to do it, aside from tackling the... So just recently, the International Science Council developed, put out this call, they're calling this new framework the Science Missions for Sustainability. And they've developed different publications, Unleashing Science, Flipping the Science Model, which I will talk about in a bit. But I really want to encourage you, if you can, to read this, because these are very interesting and eye-opening reports and publications, where the International Science Council understands that the many global challenges that we face at the moment, they need science that works with society to generate actionable knowledge, and this notion of reimagining science not just as a passive observer. You know, we always say that science is objective, right? That science, we just observe, we put the facts and whatever. But if you really are after transformation, sustainability, if you want to tackle the issues on the ground, the way science is performed needs to change. If science wants to be a part of this conversation and wants to be an active agent of change, then science, the way we approach science, can be different. Again, I'm not saying that disciplinary orientation is not important. It is. But for those of us who want to do a bit more, who want to actually contribute to addressing these wicked problems, then there's another way to kind of do it. So the ISC has this notion of science as a mission, science missions. One example is the Apollo mission, for example, when they had one goal, and their goal was to put man on the moon, right? And so the NASA put together different expertise. They have the engineers, they have even the medical practitioners have to understand how the body system would work in outer space and all that. So they had this mission and they were successful. So they're saying that perhaps if we want to have missions for sustainability, we should be oriented in that manner. We should have a very clear goal, and let's set up the system there. Oops, sorry. Another mission could be the recent COVID pandemic. They had one mission is to address the issue of the pandemic, to develop a vaccine. And so you had all these different experts coming together internationally, locally, and wherever, and they were exchanging information. The borders between, in the past, when you say, oh, this is just I don't want to share my data and all that, it's being shared very quickly. So this was another example of a mission. And in the ISC's framing, they call it the flipping the science model, where it's different from a normal research linear kind of activity where you start with a curiosity-driven science. But they're saying, what if we design the research around the wicked problems in order to solve them? It's not just the scientist saying, oh, I did this research, I have a solution now, this is my policy. You know, many of us always say, I want a policy, I want to develop a policy paper, policy briefing, and I want to give it to the government. But more often than not, in my experience, I've done that many times, the government people never pay attention to my policy because they were not part of it when I made my research. So flipping the science model that ISC espouses is, instead of the ideas flowing from our laboratories, for example, from our research fields to society, what if it begins from the fields? What if the farmers themselves identify what kind of issues need to be addressed, and we build the science around them? We build a team of experts, not just one discipline, but many, to help that. And that it's not just the scientists who give the solutions, that we actually co-design it with the stakeholders on the ground. So that's kind of what the flipping the science model is. And again, this is kind of just a kind of difference between what a conventional research process is, which is very linear. We have our hypotheses, we have our methodology, and then we gather the data, we implement it, and then we end. But when we talk about transdisciplinary research, we're really talking the issues of co-design, co-production, co-creation, different types of co-implementation even as well. And it's not a linear process, it's very iterative because we have to continuously move from one to the other. We continue to discuss, and these are some of the attributes of TD. There are many definitions, but we don't have to argue and have a debate about, oh, that's not TD or this is TD. But for us, it's trying to maybe I have some of these attributes, and then we can say it doesn't really matter if it's TD or not, but this is one way of doing it. So again, we say that TD is aiming to solve complex real-world problems. We're bridging different types of knowledge systems. And these knowledge systems are not limited to the academic knowledge alone. We're also looking at indigenous knowledge. We're also looking at practical knowledge from the policymakers, from the business sector, the implementers. We're also looking at mutual learning so that the scientists have to take on a more humble kind of demeanor where we want to learn from others, especially from those who are not. Sometimes we have our own, I'm an expert, I'm a social scientist, but the natural scientists are saying the same thing, another matter. But we have to learn from each other if we truly want to solve issues on the ground. And again, another aspect is a systems approach. It cannot be done on a sectoral approach. If we want to address flooding, for example, and later on, I believe one of our speakers can talk about it, it's not just an infrastructure issue. All right, it has to be a systems looking at not just one municipality, looking upstream, downstream, and everything. So it has to be done that way. And also for scientists to have a strong, conscious normative position, integration of different perspective, paying attention to relationships, power, and trust, embracing diversity, and having very context identification. And why? What are the benefits? We're talking about the social robustness. When a community helps build a solution, they own it. It doesn't fail the moment that the researchers leave. They can continue. We also want to have some kind of anticipatory power where we can see the side effects as we implement a new technology or policy, and then we can reiterate. We can, we can iterate and go through the same process again before they become a social crisis, right? So you can anticipate, you can do, you can tweak it as we go along. And also, again, unbordered minds. And we want to be able to train a new generation of professionals who are kind of T-shaped, who are deep into their field, into their own expertise, but who have wide in their reach. They're able to integrate and work and collaborate with others. That's kind of the things that we want to do in our Gaia project. We want to train and build the skills and capacities which may not be really taught in university in curriculum at the moment, but we feel that this is important, that we should be able to learn these things. Again, we are at the crossroads in Asia. Our problems are too big for one mind, one discipline, one department, or even one country to solve. And so we're saying we don't need fewer specialists. Specialists are still very important, but we need specialists who can border cross. And because we are interconnected, to solve these wicked problems, we need this kind of unbordered knowledge. So allow me to end there, and thank you very much for your attention. We hope to have more discussion with the panel later on. Thanks.
Thank you very much, Dr. Ia, for giving us an overview of what transdisciplinarity is all about and how it is different from all other family of approaches. And now we proceed to our next speaker. Our next speaker is Dr. Percy Sahise. He is an ecologist and environmentalist who served as co-coordinator of the Upland Hydroecology Program from 1976 to 1981. And as a plant ecologist, he has conducted research on grassland ecology and upland resource management. He held key roles, including director of SEARCA in the 90s and leadership positions at UPLB's then Institute of Environmental Science and Management and related programs. He also served as Dean of the Colleges of Arts and Sciences and Human Ecology at UPLB, and held regional and international roles in biodiversity research, agricultural networks, and plant genetic resources. Ladies and gentlemen, to give us a case presentation of the Upland Hydroecology Program, let us welcome SEARCA Senior Fellow and former Center Director, Dr. Percy Sahise.
Thank you very much for that kind introduction, Dr. Sambilya, Dr. Angkog, and wow, this is a very happy occasion for me, and I was able, because I was able to see many of colleagues whom I have not seen for some time. So, well, I have this book, but I will not read it. I have this paper, but I will not also read it. I want to look at you directly. It's good that Dr. Ria has already set up the framework for transdisciplinarity or the transdisciplinary research. Because things happen everywhere out there, not because of one element, but because of the complex interactions between human or social systems and natural or ecological systems on the other hand. The two interacts all the time, and that's how things happen. And because of these complex interactions and these complex relationships, it becomes the primary reason for bringing together different disciplines. But in a menu that is not just separate, but together. And in a systems perspective, if we don't do this, then instead of solving problems, we might be creating more problems. But this is easier said than done. You need to have the appropriate organizational and process support or structure to bring this about. Now, this is the main reason why in the early 1970s, actually 1976, we decided to set up this multidisciplinary research program known as the Upland Hydroecology Program, which, by the way, is celebrating its 50th anniversary or golden anniversary this year. And we are celebrating it with a series of legacy, we call it legacy seminars all over the campus, indicating that these different units in the campus were involved actually. The birth of the Upland Hydroecology Program came about because of the observation in the early 1970s of the rapid deterioration of the upland environment, where we have the productive, protective forest cover before. This was replaced by the vast grassland areas, which does not have the same ecological functions and integrity as the forest ecosystem. So that was the big problem, no? In the early 1970s. And because of this observation and also the increasing population pressure and shifting migration patterns where lowlanders or lowland occupants started to go into the uplands because of the need for land and other resources, we foresee at that time that this problem will increase in magnitude. So this was the impetus for our formation of this multidisciplinary research program consisting of 20 scientists, 20 scientists from almost all disciplines in the UPLB, at UPLB. These were the selected scientists who have shown excellence in their research outputs and capabilities. So we were saying to ourselves, with these 20 scientists, we cannot afford to miss solving this problem of the uplands. That was in our minds when we started this. But we found out that it is not as easy as that. And the things that I will say now will constitute the lessons we have learned in trying to bring these 20 scientists from all disciplines almost to bear on this upland problem, degradation of the upland environment. And I brought this book here entitled An Introduction to Human Ecology Research on Agricultural Systems in Southeast Asia, published by UP Los Baños, UPLB, in 1984, because chapter 19 in this book describes the experience of that transdisciplinary team. So actually I can just stop here and tell you, please go through chapter 19 of this book. This was written in 1984, edited by Dr. Terry Rambo and myself, no? And this is gathering lessons from Southeast Asia on how this kind of approach are being done in other parts of the region. Way back in 1984, but several Southeast Asian groups are already trying to do it, no, in different ways. So in the next few minutes, I will just summarize the lessons we have learned from that pioneering effort in 1976, the Upland Hydroecology Program. It was difficult. It was not easy. But if you were to ask me, as one of the co-coordinator of this program, if I will do it again, I will tell you, yes, I will do it again. Because the testament or the evidence of this effort, transdisciplinary effort, is the current School of Environmental Science and Management in the Philippines, at UPLB, which is espousing this approach simply because it was recognized that it has to transcend generations of researchers, policymakers, and practitioners, simply because the world is changing and problems are also changing. So that recognition became the impetus for the institutionalization of this approach at an institution at UPLB, the School of Environmental Science and Management. And I would just like to say that the Deputy Director of SEARCA for Administration was a past dean of this school, Dr. Rico Angkog. So, what were the lessons that we have learned? No? First, in order to bring about this kind of research program, of course, first there must be sufficient support, financial support, no? And this means that there must be somebody willing to support a program that involves a very important environmental issue or natural resource management issue. So at that time, we were very fortunate to get funding from 3 national institutions in the Philippines who are directly related to the management of the uplands and the Ford Foundation. So at that time, the Ford Foundation did recognize that this is going to be an important area. And Heinz, I think you were part of that. And it's a big surprise to have this chance to see each other again. So that's one, funding. What can you do with, how can you start a program without any funding, no? And at that time, funding, as you know, is actually geared towards specific concerns or disciplines, no? So when we proposed this to our funding agency, here they said, that's not crops, that's not animal science or animals, that's not soils, that's not engineering, because it's encompassing, no? It brings together different areas and different concerns. So that was one of the requirements. Second requirement, there must be a group of scientists who are not only credible in their own science or discipline, but must have concern and a commitment to contribute to rural development and sustainable development. That's another item, another characteristic that we sort of recognized looking backwards in perspective why we were able to bring these 20 scientists together. And third, of course, is they are good scientists in their own disciplines. So these were the indicators that you can actually form this multidisciplinary team, but not yet the ability to transform it into transdisciplinary. Not yet, no. Because our group, they were all good scientists, but they are good scientists in their own disciplines. So we have to promote a procedure or a process to facilitate transdisciplinary work. Ano ito? What are these? One, we must have regular seminars and both formal and informal discussions. Yun. We need to discuss. We need to converse with each other, the different disciplines. This was pinpointed by Dr. Ria earlier on. Two, we must have, we must create a common vocabulary, because different disciplines have their own vocabularies, We need to have a common vocabulary to understand each other. Third and most effective is the need to go out into the field and immerse ourselves in real situations so that we can relate our disciplines to on the ground, dealing with actual problems. No? So we used to ride together in our Ford, in our vehicle for long distances because we had 4 field stations outside of UP of Los Baños. But our main field station is just here in our backyard, Mount Makiling. We established our field station there. But we have 4 other upland field stations all over the country, which serve as an immersion field for different disciplines to discuss in the field, but relate it to actual and real situation. That softened the strong disciplinary dialogue as we anchored it on real field situations. So don't discuss transdisciplinarity in the laboratory or classroom. Bring it out into the field, no? And immerse yourselves in actual situations and discuss this with farmers. Absorb their local knowledge, but try to be humble enough to accept that this traditional knowledge has been honed also by generations. No? So that's another facilitating factor. The other is an appropriate organizational support system. Because researchers will find it hard to work if there is no appropriate support system. Timely enough, but effective also, so that it can provide the necessary support system. There are a few more, and the other one which we found to be very important is to bring together these different scientists with different disciplines to come up with a common systems framework with the issue, whatever is the issue, at the center, no? So bring the different disciplines together in a systems perspective where you can try to connect your different disciplines to how the complexity of an environmental issue can be understood, and therefore find solutions to it as it applies this systems framework under field situations. No? So those were some of our experiences. And what were the obstacles? Well, at that time, we were fortunate that funding was no longer an obstacle. No? We had some problems with national funding or agencies from national agencies because of the budget period. But we have the Ford Foundation funding, which tried to sustain us during the last 6 years, no? For the period of 6 years. That's how long the Ford Foundation provided us with this life support fund for the project. So what were the obstacles? One is the funding, of course. You must have secure funding. The second obstacle is that at the university level or under a university environment, it is very difficult to get credit for this kind of work at the time, 1976, 50 years ago, because it will be very difficult for you to get a publication simply because the journals are mostly oriented towards disciplinary subjects. So I'm very glad to hear that Dr. Ria said there are already certain journals or publications that will recognize the importance of transdisciplinary outputs. At that time, no publication, no credit at the university. So that was one difficulty. The second difficulty, of course, is the difficulty of scientists to work with each other because of differences in personality, differences in preferences and priorities for research, and also because of methodological differences. Add onto it cultural. If you have a transdisciplinary program, research program between cultures, East, North, and South, for example, no? As we have experienced here in SEARCA in the implementation of one of our projects. So, conclusion. 50 years ago, when we started the Upland Hydroecology program, there was no example, of course, for us to learn from. So we have to do it ourselves. So it's like, if you want to plant rice, you go out there and plant rice. But it was a very good exercise because the importance of transdisciplinarity or the transdisciplinary approach was recognized and has been institutionalized. We have learned a lot from it. At the end of the day, in the words of Dr. Norman, in 1974, and I would just like to quote here, a research worker who is often academically oriented in a single discipline makes great effort to preserve what he considers the integrity or supreme relevance of his discipline, which is softened by the context with physical realities. So these physical, biological, and social realities as a system provides the essence of transdisciplinary work. So, maraming salamat, and hopefully I was able to impart some lessons we have learned from that Upland Hydroecology program 50 years ago. Dr. Cuevas was part of that. Thank you.
Thank you very much, Dr. Sahisi, for sharing with us those lessons from 5 decades ago. A lot of them we still find relevant even until now. Thank you very much, sir. And at this point, we're going to hear more experiences from different countries as well. We proceed to a panel session on country experiences of transdisciplinarity in action. So we have representatives from Thailand, Japan, India, and the Philippines. Let us begin with our first panelist. From Thailand, we have Dr. Siwat Pongpiachan, a professor at the National Institute of Development Administration in Bangkok, Thailand. Sir?
This the this one, this forward and this back. Okay, thank you. All right, good afternoon, everyone. It's my great honor to be here today. Thank you for Dr. Ria for inviting me to be a part of this prestigious conference. Today, I'm going to talk about the case that we had done in Thailand. So I also act as a national project manager of UNIDO projects, or United Nations Industrial Development Organization, which is UNIDO, and also we have collaborate with PCD, Pollution Control Department, which is the organization under the Ministry of Natural Resources and Environment, and also collaborate with Ministry of Industry. So today I'm going to talk about the transdisciplinary. We are trying to encourage the private sectors to reduce, dioxin emissions. As you know, that dioxin is one of the most toxic, mutagenic and carcinogenic substances, and it's normally released from the fossil fuel combustions. So in most of the factories, they come from the industrial boilers. So we are trying to find a way that to compromise. Well, actually, we are, of course, as an environmentalist, we aim to trying to find a way to reduce dioxin as much as possible. But of course, we need to compromise to the private sectors as well, because without having industrial boilers, they can't do any activities. So how can we encourage the private sectors? It's the most important. I think it's the keywords in terms of the sustainability. So, yeah, as I mentioned, it's a PCD and NIDA. I'm also a professor at NIDA, National Institute of Development Administrations, and we have a long collaboration with PCD and UNIDO for nearly 10 years. So I have done so far about 5 projects of UNIDO, but today I'm going to talk about 2 projects of them. All right, so maybe I think you know about Red Bull. This is one of the most famous company. I think it is internationally recognized a company originally from Thailand, Red Bull. But please don't mix Red Bull with whiskey. It's too risky. So the company I'm going to talk today is a Red Bull whiskey company. So they also produce a whiskey as well, the Red Bull company, and of course they have a lot of industrial boilers, and also they have a lot of waste from fermentation, and that is molasses. So this project really, I'm honored to present that the director of Jeff at the time. So I think it's 2016. It's quite nearly 10 years ago. Madame Naoko. So, and Dr. Gustava. So, Madame Naoko is a chairperson of Jeff at that time. As you know, that Jeff is one of the most prestigious funding agencies related to the environmental issues. And Madame Naoko herself came to Thailand for visiting the Red Bull factories, because I also published the paper, and it attracted a lot of attentions on how to promote the private sectors like Red Bull to interesting in terms of the BATPEP to reduce dioxin emissions from the factories. So this is the Red Bull company, Red Bull whiskey. So you can search from Science Direct. This is my publications related to these projects. One of them is we use the micro emulsion system to enhance the efficiency of the combustion efficiency, and at the same time reducing the use of the heavy oils. Nowadays we have an oil shock, not only in Philippines but also in my country, in Thailand. We are, because of the Middle East crisis. So that's the key point, that we in Southeast Asian countries we have a lot of agricultural waste. So there are many ways that if we can utilize the waste, like using for example, flash pyrolysis. So we can turn the biomass into pyrolysis oil, and we can further distill into benzene. So this is the thing that we need to think. But okay, anyway, for this project, I'm not going to talk about the pyrolysis, but I'm going to talk about how to utilize the molars, which is the waste from the whiskey production process, and then we use the methanol from molars, and then put into the micro emulsion system to reduce the use of heavy oils, and therefore it can reduce the dioxin emissions as well. So this one also published in Taylor and Francis, polycyclic aromatic compounds. You can also visit. I think it's a free access. It's a free PDF file that you can download from the internet. And of course, okay, this one as well. So this is 4 papers together related to only one project that we had done with collaboration with Red Bull. So the background is, okay, not only PAH, but also they have many persistent organic pollutants, which, as you know, in Stockholm conventions, they have a 12 dozens of the POPs. That including PAH, PCDD, PCDF, okay, that's dioxins. And mainly it's come from the imperfect combustion from industrial boilers. So, yeah, we are trying to find a way to reduce this. So, in order to conduct this project, we are also monitoring before and after the installation of micro emulsion system. So this is the pilot plant survey in Red Bull. All right, so this is the concept. How can we reduce the dioxin emissions? So first, we use what we call the surfactants. So we use the surfactants, which is can combine like water and also oils. At least we use heavy oils, and also we use alcohols from molars. So there are 3 types that we test in this project. First, a pure heavy oil. The second, the mixture between heavy oil and water. And the third one is the mix between alcohol, water, and heavy oils. And use the surfactants. And then because of this, we can reduce the droplets of the fuel. By reducing the droplet, it can enhance the surfactant area of the droplets, and therefore it can enhance the combustion efficiency. And at the same time, because we use alcohol and water, we can also reduce the use of the heavy oils. Right, and that's why this project can reduce the dioxin emissions. So the micro emulsion system that's providing the mixing of oil, because it's bunker C, with water with high strength magnetic fields to generate atomized fuel droplets. And the droplet sizes can be reduced to 0.15, between 0.15 to 0.5 microns. That's nearly, the original one is about 50 microns. So it's a lot more than 10 times. And because of that, it can enhance the combustion efficiency and therefore to increase the capability of contacting oxygen. So yeah, as I mentioned, there are 3 types: 100% of heavy fuel oil or bunker C, 90% of HFO plus 10% of ethanol, and the 90% of HFO and 10% of water. So the study site is the Red Bull Distillery factory, which is located in Samut Sakhon province, not so far from Bangkok. Right. So we also have a stack emission analysis to detect the dioxins. To sampling dioxin is not easy task. It's very complicated and need a long time. Even the analysis themselves, we have to send it to Belgium. So now we have the facilities to analyze dioxins in Thailand, but it's pretty limited. We also have the former name is ERTC, Environmental Research Training Center, which is sponsored by JICA. But now they change into the Department of Climate Change and Environment. But they still have the Institution of Dioxins in Thailand. But this project, because it's in the middle of the establishment of the Institution of Dioxins, so they are not ready to analyze for us. So we have to send this to Belgium for the chemical analysis. Okay, and we have to use the high resolution of GCM-SMS. And also we detect the trace gas like sulfur dioxide, NOx, and CO as well. So they have 17 PCDD and PCDF congeners to quantify, and we use the NIST SRM 1649B to ensure the quality control and quality assurance. So the key results, what we have found here, as expected, they have the significant reduction in terms of PCDD, which is that one of dioxin interference emissions, and this is the emission factors that we found in 100% is about 1.6. So the heavy oil with ethanol is about 0.58, and heavy oil with water is about 0.5. Okay, so this is before and after. As you can see, the relatively more clean inside the industrial boilers after using the water and the mix with the ethanol. Okay, this is the, I'm not going to talk in detail. It's about the congener pattern shift that we had found. But what I would like to highlight is the ethanol contains very low chlorine. And therefore, as you know, the chlorine is one of the main element that construct the dioxin, like TCDD. They have the full chlorine outside the benzene rings. And the water fuel micro explosion improves the atomization and mixing, and it can reduce hydrocarbon pyrolysis with a lowest formation of higher chlorinated PCDF. So the micro emission system likely to minimize the surface catalysis pathways. Okay, so I'll go to the conclusion. I don't know how much time do I have. I still have time. Few more minutes, because maybe I have to skip the second project. It's going to be long, but okay, I will focus only to this project only. Okay, so the conclusion will be the micro-immersion systems significantly reduce dioxin emissions, so especially with 10% of ethanol, and also related with a lower nitro-PAH formations. So what is nitro-PAH? We know PAH is a carcinogenic substance, but nitro-PAH has 1,000 times more toxic than the native PAH. So this is why how to reduce NOx is also crucial, because NOx can react with PAH and generate nitro-PAH, which is 1,000 times more toxic than the native PAH. So we are trying to promote the industrial sectors to utilize the idea of the BAT, which stands for Best Available Techniques. So micro immersion is one of them. But there are so many BAT, like economizers. They also have more high efficiency, supercritical boilers, for example. So that's something that best available technique. And we also have best environmental practice, like how to optimize the oxygen flow, how to clean regularly the industrial boilers, and it can also enhance the combustion efficiency. So what is the most challenging things in this project from my perspective? I have to convince the industry sectors. So by setting up this, I'm going to show later, yes, the investment cost. So now we need economists to help us to convince the private sectors about the payback period. By investing, okay, like it takes about 137 and 500 US dollar. So this is the cost that maybe the private sectors need to invest. But luckily, UNIDO, with the assistance of Jeff, also co-funding for this project as well. That's about 30,000 US dollar for the micro emission system. So it can save the heavy oil, which is cost about 41,000 liters per month. And that's about 6.9 million baht in that day. About all it can convert to 213,729 US dollar per year. So by knowing that cost, we can calculate the payback period. And the rest will be the benefit for the private sectors. So yeah, I would like to end my presentation there. And I think we are looking forward to have a similar projects elsewhere that can, encourage the private sectors to invest in BAT and also the BEP. BEP is something that doesn't cost any money, but we need technicians to optimize the oxygen. And sometimes the private sector, they don't care about cleaning the industrial boilers. By cleaning routinely, it can save the money by increasing the combustion efficiency and therefore reducing the use of the heavy oils. And because of that, the less dioxin emissions will be. So yeah, this is the thing that we think that our friends around the world need to look at. And thank you for your attention.
Thank you very much, Dr. Siwat, for the presentation. We head to our second panelist from the Department of Japanese Food Culture of Kyoto Prefectural University, Japan. We have Dr. Hein Mali.
Good afternoon. My name is Hein Mallet, and I'm now, as just mentioned, at the Prefectural University of Kyoto. Until a few years ago, I was with RIA at the Research Institute for Humanity and Nature, deeply involved in Future Earth in the Asia region. And to some degree, I'm still participating a little bit. What I wasn't going to talk about today, but after encountering Dr. Percy, I changed my plans a little bit. I, for about 15 years, was not an academic, but a practitioner. At least that's how I like to think of what I did. I was a program officer with the Ford Foundation and later with Canada's International Development Research Centre, IDRC. And in that capacity, I worked with researchers and NGOs throughout, well, I was going to say Asia, but Southeast Asia and China, on a lot of these issues mentioned today. And I want to reflect a little bit on the role that the Philippines' experiences have played in the wider region, because this is something that may not be widely known, but has been significant, I think. And with experiences in the Philippines, I refer to a broad set of participatory, engaged activities and research, of which the uplands work, I think, is one example, but there are many more in coastal resources, for example, in forest management and others. And I think there was, from the 1970s and 80s, a sort of indigenous development of practices. First of all, I think based around community mobilization and engagement. And there may be some links with sort of the political situation of the country at the time and all that, but where effective organizing of the community allowed all kinds of interventions to combine with research and lead to results in a participatory manner. Multi-sectoral stakeholder platforms, etc., bay-wide councils and what have you, I think is another characteristic of that work. And the focus on what at the time was called changing the bureaucracy. One of the obstacles in many cases was the fixed sort of routines of the government institutions, and that by changing some of that, it was thought new practices can have a chance to develop. And this mixture of participatory approaches, I think, was first and foremost developed by the researchers and the practitioners and the communities in the field here in the Philippines, but was, I think, recognized by the Ford Foundation as being really significant. And the Ford Foundation provided fairly generous support for some of that work. Most of this happened before I joined the Ford Foundation, I must say. I'm not talking about my own work directly, mostly. And Ford had offices in Indonesia, in Thailand at the time, in China and India, and very actively promoted these sort of experiences from the Philippines, outside the Philippines, by funding locally active people in those various countries. And I think for a long time there was a style of a flavor, or you might call it, of participatory rural development, community-based forest management, biodiversity related work, participatory technology development, etc., that were inspired by this combination of the Philippine experiences with Ford activism in the region. And so I think to this date, you can probably find in Southeast Asia and Southwest China people and maybe traces of the activities that were really developed here in this country. So I would just want to acknowledge this and maybe even put it on the table as something that somebody one day might write a PhD thesis about or something like that. That would be very nice. But so I really appreciated this. And it was today meeting with Dr. Percy for the first time, even though I had heard about him many, many times before, that sort of made me think of this influence of this country in the region and share some of this with you. I will add a little bit about Japan, not too much. I have lived and worked in Japan for the past 15 years and also earlier, and in that the capacity of my work with Future Earth as well at the Research Institute for Humanity and Nature has brought me into contact with many researchers who were struggling in some senses, but working hard to adopt a transdisciplinary research approach. So this gives me some understanding, I think, of what's happening in Japan, even though I'm not Japanese myself. And Japan, I think, is an example of a separate tradition that was not part of that sort of Philippine origin approach to transdisciplinarity, but Japan, partly because of language barriers, I think it tends to have its own sort of way of doing things. And there have been for a long time researchers, especially in rural sociology, but in development, welfare, fisheries, infectious disease, etc., who engaged in what they never called transdisciplinarity, but kinds of action research that shared many of the characteristics that Ria earlier mentioned as being typical of transdisciplinary research. And in particular, what I find interesting is that the rural sociologists and in some cases anthropologists, etc., are people who in their academic capacity are completely focused on the grassroots. But many of them have a very academic stance when it comes to interfering or intervention in the practice in the field. So there's a substantial part of researchers who know this particular community or this area really well, but insist that as a researcher they have to ultimately be sort of separate from the community and not directly intervene. Against that, there's another sort of school of thought where people want to capitalize on the intimate knowledge of local communities and situations and actually facilitate processes of finding solutions in a participatory way. And there's been some reflection and dialogue about this, and people also write about these sort of debates and the mental struggles that they had in sort of sorting out their thinking on these issues. This is one thing. The second element that's been quite important for transdisciplinary, the interest in transdisciplinarity in Japan has been Future Earth, in fact. And I think that now 15 years ago or so, in 2012, 13, etc., etc., when it was becoming clear that Future Earth would be created out of these pre-existing research programs and that transdisciplinarity was going to be an important element, there was quite a big outpour of interest in Japan in transdisciplinarity. And not in the traditional rural development and sociology circles, but among often natural science researchers. So people who, like the people I just mentioned, felt that, or had felt that you should not interfere, that proper research is independent, neutral, etc., and is not engaging with changes that the researchers will write their papers, and the papers may be used by others for solving problems. But I think the emergence of Future Earth and its insistence on transdisciplinarity in some ways legitimized the position that research should be engaged and should be focused on finding solution in collaboration with local stakeholders. So the Ministry of Education, MEXT, as the first one, but also GST, one of the major research funders in Japan, were seriously interested in sort of what all of this meant and what they could do to contribute, partly contribute internationally to Future Earth, but also contribute in terms of funding research and funding research about how to do this, etc., etc. In the end, I think not so much has come of that, to be honest. And this is partly similar to what happened to Future Earth in other places around the world, is that there had been pre-existing funding, but when Future Earth was created, in many countries that funding disappeared, dried up, and the government funding agencies, for some reasons, was not so interested anymore in funding this kind of work. I think the Philippines are a bit of an exception, where there has been government interest and support, and where there is a lively Future Earth community. But anyway, there was a wave of interest in transdisciplinary research, and lots of projects took place, but that the heat sort of has cooled off, and it's no longer such a hot topic. However, as Ria showed, there's many places in Japan, universities, where there is a transdisciplinary center or institute or something like that. So to some degree, this wave, I think, has become institutionalized, not on a very large scale in the sense that a major proportion of Japanese research adopts this kind of approach, but there are sort of organizational focus points throughout the country where some of this work still continues. Yeah, maybe I should leave it at this one. Okay. I had some more things, but I'll stop. Thank you very much.
Thank you very much, Dr. Hain, for sharing your insights. So we proceed to our third panelist from India, who is joining us via Zoom. We have with us from the Divechas Center for Climate Change, Indian Institute of Science, Dr. Shruti Subana. Dr. Shruti, are you here?
Yes,
Can you
yes,
hear us?
yes.
Yes. All right. You may proceed with your presentation.
Thank you so much. So I have to ask the standard question that my screen is visible. I am audible.
Yes. You can put that on full screen, and
Yes.
there you go.
So considering, the audience and what I have done in the past, I thought maybe it would be good to start with something that we did on bamboo-based farm forestry. So just to give, a kind of a background as to how or why we started this study, it's that there was a lot of concern amongst farmers with one particular bamboo species, which was being grown quite extensively, especially in, the peninsular region of India, which is, the southern part of India. And it was found that, the promises that were made were in terms of how economically beneficial it would be, or, its growth itself, it was not found so much up to mark. And that's how, there were a lot of complaints that went across, the scientific board and also to at the governance level. And that's how we started working on it. So we looked at it from 4 different aspects. There's a whole team that was working on it. And so from a social angle, what we wanted to do, what we wanted to understand is why is it that farmers are growing more and more of the species? And honestly, what came out through the study was, there were the first 3 or 4 components that were more or less, similar across the 3 states where we conducted a rigorous, survey. One of the key aspects was the availability itself. These bamboo species were a lot more easily available because it was also adopted by a lot of nurseries and it was kind of spread across these regions. There was this perceived economic benefit. There was also this perceived management or ease of managing this bamboo itself that was there. So these were, kind of the main reasons why farmers were going more and more towards it. And when we dug in deeper, we realized that if there are other, species that are available, especially those that were endemically and indigenously more prominent in the regions, then they would very well opt for that. But the lack of availability made them want to go to, this bamboo species. We also try to understand the economics of this versus, other species that were more indigenously available. Now, this comparison is primarily across different bamboo species. So, Bambusa balcoa that you see in the first line is essentially the introduced bamboo species, and then the Dendrocalamus toxii has been indigenously present in a lot of these regions since years, and it also has honestly a lot of religious and cultural significance in the region. It's used in their festivities and so on and so forth. And if we actually look at it, just from an economics perspective, we see that Stoxii is way more, economically beneficial. So that perceived economic benefit somehow does not hold true when we actually, went ahead and kind of tried to analyze it a little more deeply. We also looked at it from its basic physiological parameters and also the amount of biomass and the carbon that it sequesters itself. And in terms of the growth parameters or even the biomass itself, we found that there was a very interesting correlation that we found. So something that is a 6-year-old bamboo in probably the humid region would be equal to, say, a 10-year-old bamboo in the semi-arids or in the drier conditions itself, making it quite evident that this bamboo species essentially would it's more apt for growing in the humid regions. You can, of course, grow it in the semi-arids with a lot of added irrigation and so on, but it just grow better in the humids with lesser interventions itself. And finally, we tried to, use some kind of technology, some modeling techniques. We use something called as ecological niche modeling to identify where would, these species grow ideally well in the country itself. And what we found is that, it's more in the humids, or if you see, in the west coast of India, which is where the Western Ghats is there, and it's high on humidity, very heavy rainfall throughout the year. So those are the regions, or even in the northeastern part of India, again, which is very humid and high rainfall region. That's where these species grow well. We also, of course, validated it, with the ground level data sets that we collected, just to ensure that, the model that we have used, the results that we have obtained, it's kind of a valid one. So essentially, through this project, and here I have just, like crammed in the main findings of the study, is that the idea was to get a more holistic view of the bamboo itself, the bamboo sabalku or bamboo itself, not just from a social aspect, but also from an economic aspect, understanding its physiological characteristics, how well it grows, its ecological perspective. And through these, various exercises, what we've done is we've come up with, matching species with site for a few of the bamboo species, including balcoa. So what are the regions where, these species would grow well? We have also created a technical bulletin on what are the ideal farming practices, for dissemination to the farmers, and it's also being translated. It has been translated to a couple of local languages here and is being translated to more. We also tried to get in a few policy interventions, because one of the key findings was that there is a lack of diversity in terms of the planting material available itself. So how do we enhance or have a greater diversity in terms of the planting material, and also in terms of the transportation? Now here's where we found a huge policy gap, that whenever you have these different states and it has to cross state boundaries, any kind of material, then it becomes a huge problem for the farmers. There are taxes that are involved. There is no uniform rule, so we try to get in those aspects into it. So this is something that we have done in India. And I think Ria mentioned about the whole Asia Science Mission itself. So I think I'll just touch upon Asia Science Mission and how we're looking at it through the different co-phases, she said. So we have a co-understanding of the problem itself. How do we co-design, the methodology, co-conduct the research, and co-production of the knowledge material itself. So one place where we are working on, or one of the demonstration projects for Asia Science Mission is located in West Bengal, which ironically is the east of India. And there is a block or a district called as Purulia. That's where this entire project is happening. And it has some key problems or key challenges that the region faces. One is it's very dry. It's semi-arid. It's extremely drought prone. Especially the summer months are very dry. Soil erosion is very prominent. The topsoil is almost negligible, and any kind of even small runoff and you have soil erosion. And all these leads to shrinking overall resources itself, driving migration, erosion, and loss of a lot of traditional knowledge itself. So considering, or given this background of the region itself, how do you co-understand the problem? So there were, some interactions that have been conducted by Sanjeevan, which is the, local organization that works there, with the local communities itself to understand, what are their key concerns, what are their problems itself. And one key thing, of course, that came out was, water is a huge matter of concern itself. So there have been certain interventions that have been done, wells that have been built, or series of ponds that have been built, but still summer months are a little challenging in that aspect. So we are right now in the co-design phase, where we are asking the communities through surveys to understand what do they think are their problems, and how do we work towards solving it in a more holistic manner. And through ASM, essentially what we hope to achieve is the whole strengthening of the capacity itself of the communities living in the region. And particularly, how do we look at ecological restoration itself in the region? How can we refine the approach to the problem itself? Because Sanjeevan has worked there for quite some time, but one of the key aspects is the sustainability of the solutions that has been done. That's one of the issues that they face. So how do we approach the problem, diagnose it, so as to ensure that it's more sustainable itself? Um, Identify policy linkages. There are some policy gaps that are always in existence, and how do we blend in the national plans with the state plans to ensure that the results are better? And how do we create a lot of this knowledge material that can be disseminated to kind of uplift the entire community itself? Also connecting it to potential co-funders for long-term sustainability of the project itself. So that's something that we're trying to look at, we're trying to aim for through the mission itself. And I end here. Thank you very much.
Thank you very much, Dr. Sruthi. And now our final panelist from the Philippines, from Future Earth Philippines, we have Ms. Dada Doble.
Ako makita. Okay. Magandang hapon po sa inyong lahat from the Philippines. Kailangan ko magtagalog kasi baka mapagkamalan yung ako yung taga-Mongolia. Anyway, good afternoon po. I'm Dada from the Future Earth Philippines. As a background lang, I would like to tell you that the Future Earth Philippines was actually established in 2018. It was funded for several years by the National Academy of Science and Technology. And that was the reason why after po nung ito ay founded and established in the Philippines through the National Academy of Science and Technology, we were able to conduct collaborative efforts, collaborative work with the DOST, Provincial Science and Technology Offices. In Tarlac and also in Pampanga. So, meron po yatang ipapakita na poster, no? Ang tawag, the program is called, or the project is called the Mount Pinatubo Region. Sorry, that's just the poster. The Mount Pinatubo Region Resilience Escalator Strategy. Okay, so if you will notice, yan po. There's an escalator there on the right side because the Mount Pinatubo, this project wants to help the region, not only one particular province, because as mentioned earlier by Ria, the problems are not only problems of one community or one municipality, but specifically in the Mount Pinatubo region, the problem also is being experienced by like the provinces in the Mount Pinatubo region. This started when the Mount Pinatubo erupted in 1991, when lahar flowed and the sediments actually blocked the waterways. Now, so Mount Pinatubo is actually a regional resilience strategy that helps communities move progressively. That's the reason why there's an escalator, because we want to move the communities from immediate risk reduction to systems capacity and strengthening, and towards adaptive and transformative resilience. So it was not delivered to only one LGU, but to some, more LGUs. It was co-created with them through shared problem framing, joint knowledge production, collective planning, and prioritization. It's an iterative refinement of strategies. So what we did was, the first thing we did was to conduct scoping activities in the provinces of Bulacan and Pampanga. because these are the municipalities in Pampanga and Bulacan are flood-stricken. Though there's many municipalities, especially in Pampanga, wherein the whole year round, their place is flooded. So what we did, we partnered with the provincial science and technology offices to ask the communities themselves through the community resilience and transformability scorecard. We have this scorecard that we administer through the 22 barangays in Pampanga. So to ask them what their problem is it really flooding or any other problem? So that's actually the start of co-designing. We believe communities know they have different perception on their problems, not only flooding. And would you believe the results that we found out is that they don't consider flooding as a problem anymore because they don't have any aspirations anymore. They've been living there for like 40, 50 years, and they were saying, it's not a problem for us anymore, and we don't aspire that it's going to be solved, the problem of flooding. So we were very fortunate because one of the members of the Future Earth Philippines became a member of the coordinating unit of the Asia Science Mission. So because of that, we were able to conceptualize a project that will somehow help the communities in Pampanga through co-designing. So we were saying that ASM's distinct approach to enabling change will help the communities in Pampanga for the reason that it's long horizon engagement, not projectized intervention. We co-design for research agendas, capacity building, and that's what we want to do for the LGUs, the HEIs, the high educational institutions in Pampanga, and also the DOST, Provincial Science and Technology Office, especially the communities. No, we want to capacitate them to be able to, for them to think of how they will be able to solve their own problems, and not us telling them that these are the solution to your problems. So we want to integrate citizen-generated data, local governance practice, and formal science and planning tools. So with the distinct features of Empress under the ESM, we also want science to be embedded in local government reality, universities as capacity partners. Now we are actually establishing university sustainable development goal action networks. We have formed, we actually invited 3 universities from Cavite State University in Luzon, in Mindanao, the Eastern State University, and in Mindanao, the MSU IIT, to be able to help in also creating solutions to some of the problems. For the communities, we also did what you call this problem tree analysis, wherein the communities together with the LGUs, the NGOs, and even the Regional Development Council in Pampanga and Bulacan, they were able to identify their problems, but unfortunately, they think flooding is not a problem anymore. They think it's something that we cannot solve anymore, but they just want to be able to live their lives even though they're flooding more comfortably. So the local government as primary resource holders using their mandates and their budgets. So we are saying that because there's funding from ASM, is that we're not going to look for other funding for the project, because this is co-design. We want communities as knowledge producers, not just beneficiaries. So we're planning to establish a regional council wherein provinces in the region of Mount Pinatubo will be able to participate. So we can ask them for support, not only for funding, but also for support for other resources, their expertise, so that it will become transdisciplinary also, like what we are doing here. So we think that this event that we're doing here now is going to be very beneficial for the project, for the reason that it will be able to enhance our approach in dealing with our stakeholders. And we also think that this will strengthen the Empress co-design process. It will also institutionalize transdisciplinarity practice in Empress. And it will also improve our capacity building program. So we are hoping that in the next 2 days that we're going to work tomorrow, and then we'll be able to come up with some more concepts to be able to help the communities in Pampanga. Maraming pong salamat.
Thank you very much, Dr. Dada, for your insights. Okay, so that wraps up our panel sharing session. At this point, we're just waiting for Dr. Angkog for the moderated discussion, but maybe we can open the floor for any questions from the group. Thank you so much for staying, even if it's beyond 5 p.m. already. Any questions from the group? Yes, Ms. Lichelle. Kindly use the microphone.
Hello, I'm Lichelle Carlos. I'm the program specialist from SEARCA Emerging Innovation for Growth Department. And I'm also proud to say I'm a PhD student at CESAM, sir, taking up one of the newest courses. It's Environmental Diplomacy and Negotiations, which is a very transdisciplinary course. So my question is, I think in the academic sector, we have been, or our educational system has been such that has been so traditional such that we are rewarded for individual work and for individual expertise more than collaborative results and transdisciplinary outcomes. And also we are rewarded for very deep expertise rather than being rewarded for transdisciplinary results. My question is, maybe for any one of you, but especially for you, Dr. Ria, have you had experience or can you cite success from universities, maybe even from kindergarten, from schools, from elementaries, where there are strategies to make transdisciplinary work more effective and more rewarding, and I don't know, and to really move it to a mainstream modality? So I think, sir, you mentioned, Dr. Hein, you mentioned that it's not very popular anymore. It used to be a hype, but there's no funding anymore for transdisciplinary work. And in a way, I think because it's a method rather than really a topic. So, ma'am, what are your thoughts? And the others could probably chime in. Thank you so much.
Thank you. Yeah, that's a very good question. In fact, I actually wanted to ask that question to Dr. Percy as well. No, but it is true that one of the barriers, especially for young researchers, to engage in such approaches is the incentive, right? If you're being, if you're for promotion, you need papers, you need all these things, and so sometimes it disincentivizes the young researcher to pursue it. On the one hand, so that's something. And one of the discussions that we have in the networks that I'm with is really to think about how to institutionalize transdisciplinary so that it can be recognized and mainstream. So that's one thing that needs to be done. In our institute that Hein and I run is actually really all the researchers are required to be transdisciplinary, and they get funding for it. So on the one hand, the positive side is that there are scientific funders who are actually interested in really funding this. So as an incentive, that could be one, so that you can be part of a consortium. But in terms of like professional career, one of the things we struggle with also is that this balance that on the one hand, especially if you're very rooted in the field, you don't have time to think about writing papers anymore. But But what I like about what Dr. Percy said is that, many of the people who engage in such kinds of activities are very committed. So I guess some of the rewards are a bit more of a kind of satisfaction or contribution to society, like social impact and all that. But one of the things that we're also looking into is trying to measure these types of the social impact is also becoming, hopefully, we're advocating that it can be used as a kind of means to assess or evaluate results. So aside from academic publications, of course, we're also trying to figure out what are the metrics to determine social impact. Because at the end of the day, social impact is valuable, right? But of course, from a professional perspective, it's a bit difficult. And then, but within the network, we're really, so for example, I was very encouraged that Hong Kong University actually developed this program. They have this Transdisciplinary Center. So the fact that they've set it up means that their university is recognized as important. And another example is Singapore, for example. They have a policy right now that they said that polytechnic universities in Singapore should have transdisciplinary as an approach. So the incentive is they have to abide by that policy in a sense. So there are different ways of looking at it. I think that could, in a way, institutionalize or serve to mainstream it more and more. But yeah.
Yeah, yeah, Dr. C, so maybe you have something to say about that.
Thank you. First of all, I am very glad that you are a student of SESAM. No, my sense, I'm now 83 years old, no? My sense is that if you have a vision, go for it. The road towards that vision might be rough, but pursue that vision. That's what we did with this transdisciplinary process that became institutionalized at UPLB. It's sheer, what you call it, determination to pursue a vision, which became that now the school, no? And not only the School of Environmental Science, but it's permeating the university. The College of Human Ecology is into it. The College of Forestry and Natural Resources is setting up programs like NREM, no? That's all towards that goal. And I think sooner or later, as a bandwagon, we are used to bandwagon types of mentality, no? The university will come up with a more formal system of recognition, no? Maybe for your generation it will be coming. It will be there soon, no? But it's just sheer vision and pursuing that vision that propelled us into this. And of course, the in economics you have this the value, the satisfaction of getting upland people or farmers, for example, say thank you for helping us develop this sustainable upland farming system. Thank you for understanding why we're doing this and getting us more information that will strengthen what we're and will add to what we're now practicing. No? So maybe that's all what as I can say now. But maybe also get an administrator in the university who has been into it and will have the perception that it is important, so you have to develop mechanisms within the university to enhance it. No? Yun lang. Thank you.
Thank you very much, sir. So that's a good warm-up question. I now invite our Deputy Director for Administration, Dr. Rico Angkog, for the interactive panel discussion. Or would you like to proceed now with the Q&A, sir? Okay. All right. So it's just an open discussion with anyone from the group who would like to raise a question. Yes, sir. Please kindly use the microphone, introduce yourself and your institution.
I'm Gil Villancio. I'm 67 years old. So I just happen to be in the middle with Dr. Saisi as 83 years old. So I have the benefit of having contact with the masters and the younger ones. No? And I happen to be a participant of what is being discussed right now. I think one thing that we have to realize that there are some sort of terms like adaptation, transformation, and all those things. So when we started the Farming Systems and Soil Resources Institute way back 1980s, no, we already actually exposing a lot of these basic elements of transdisciplinary, no, including when we started the integration of indigenous technology, for example, by the group from the IIRR, the International Institute for Rural Reconstruction, during that time. And there's actually an international network of farming systems before. And with that, they are already exposing some elements of transdisciplinary, no? Something like that. And of course, the university had been transforming as well. From Farming Systems Research and Soil Resources Institute, we become Agricultural Systems Cluster, and afterwards becomes the Agricultural Systems Institute, something like that. And from then on, we're exposing what we call interdisciplinary, multidisciplinary, and now we're saying about transdisciplinary, and all those things. So the university are actually transforming from that upland hydroecology program. Remember the agroforestry program by Dr. Del Castillo. So all these things actually. But they have been transformed into different names and different components. But I'd like to say that we're actually improving. We're adding some ingredients into it to make it more useful. From a subsoil type of technology, we started putting what? We start putting quail eggs out of it that it become more tasty. And they're making use of different ingredients to make it more, rather than ordinary flour, something like that. So make it more palatable and more updated and to the taste of the people. One thing that I'm also a part of that group who facilitated with UPLB to address yung biofuel industry. So I am the program leader of just making Jatropha corcus becomes an alternative to cocoa biodiesel and so on. But unfortunately, one thing deeper, I think Dr. Saisi will attest to that. With the different, I think somebody also mentioned about the bureaucracy, something. If some bureaucrats change, there will be some change in directions. Then some programs will be a little bit frozen, and another thing will be instituted. But it requires people like us, no? Dr. Saisi will stand into that particular advocacy. That whatever change and all those things, you might be frozen from sometimes, but the spirit will always be there. And be able to absorb, some changes, to accept that there are a lot of things that has to change, and so on. And I think I have to mention also that the university also instituted what we call the interdisciplinary study centers for various thematic areas. One for natural resource management, we have one for biofuel, we have one for organic agriculture, we have another one for water, I think we're a member of that, and then we have specifically for organic agriculture, food security and nutrition, something like that. That is an attempt to integrate all these transdisciplinary concept into things that we have to do. Then just recently, I mean, you might have heard about Agora. Agora, what is Agora? Again, Agora. But basically, this basically integrate the future things, no? As the current chancellor actually becomes an advocate of that, the future thinking concept. So at least at UPLB, future research is still not a passe, but we're still trying to push it through. The current dean of, at least two deans of the College of Agriculture and Food Science actually embraces the future thinking alternatives and so on. And there are a lot of things going on actually. So we don't have to be malulungkot, no? To be saying that things are passe and all those things. Actually, sustainable agriculture become a passe for sometimes. Farming systems become a passe, no? But we try to integrate those things into something, you know, there might be change in names, but the components are always are still there. No? And one thing that, I don't know, it's quite lengthy, but one thing that is quite, we're experiencing right now is the gap between knowledge systems. Because we were employed way back 1980s, but the next person that was employed with us is way back 2000. So there are some gap of knowledge of the current administrator. I mean, the current people involved in the universities. They are younger, and the training is not that, I mean, the systems orientation is not inculcated that much, no? So, Maria, this is something that we still have to really, capacity building style things that we have to do in order to integrate thinking like this, no? Because there are a lot of, even in my unit, the Agricultural Systems Institute, the younger, almost MS graduate, the PhD graduates already retired, and most of our staff are, you know, at the MS level. So you will expect there will be some knowledge gap. Of course, the dean of, where is he? The dean of College of Communication, Development Communication. Almost every one of us are encountering things like that. You know? The bureaucracy are really very important in espousing all these thematic or whatever trust that we want to do. Okay? And of course, for older like us, we can still always provide information, things that we have not done. I hope the younger ones can do it.
Thank you very much, sir, for adding those insights to this conversation. Any reactions or further comments from our panel? Okay, any question from the audience? Any further questions, comments? None? Okay, so now I think we can conclude our Q&A. It's past 5 p.m., so thank you so much for staying. But before that, we'd like to hear a few feedback from the group and insights as well. So we request everyone to please fill out our feedback form, share with us your insights of this seminar. And while you're doing that, we would like to award some certificates and tokens of appreciation to our resource speakers. We invite SEARCA's Deputy Director for Administration, Dr. Rico Ancog, to give the certificates and tokens. May I read the citation for our speakers? This certificate of appreciation is hereby awarded to for sharing his or her expertise as speaker in the SEARCA Agriculture and Development Seminar Series on Transdisciplinary Research in Action Across Asia, held on 23 March 2026 at SEARCA UPLB Campus, College Los Baños, Laguna, Philippines, signed by our Center Director, Dr. Mercedita Sombilia. We have a certificate for Dr. Ria Lambino. Okay, we request the speakers to also stay in front. Another certificate for Dr. Percy Sahise. The same certificate for Dr. Siwat Pong Pia Chan. The same certificate for Dr. Hain Mali. We also have a certificate for Dr. Suti Subana, who's still, I think, joining us from via Zoom. We will give the certificate to her. And finally, our certificate for Miss Dada Doble. Okay, we're gonna have a group photo with everyone. Okay. Can we request everyone to please compress po tayo to our speakers. Okay. Okay. A quick group photo. Maybe, since konti na lang po tayo, kindly join us here in front. Dito na lang lahat. Okay, dito na lang po tayo sa harap. Okay. So that concludes our ADSS. For those joining us online, maraming salamat po. Thank you for joining our ADSS today. And we hope to see you again. We have another ADSS on Wednesday. Sige po. Maraming salamat. We have some refreshments outside for our on-site guests. Thank you po.